many x's there? Like 14 times. Okay, so last class we would have done like x times x plus 2, the monomial times a binomial, right? We're all here. Cool. Today we're going to do a binomial times a binomial. A little bit trickier. Okay, let's start off by doing some algebra tiles, and then I'm going to show you, basically I'm going to show you today 3 different ways to do this. Do you need to know how to do all 3? No, but you need to find the one that works for you. Okay, so I'm going to show you all 3 so you have that exposure, but then you can pick whichever one you prefer. So in this question, this is kind of doing that area model idea again with the algebra tiles. Not a huge jump from a monomial times a bi compared to a binomial times a binomial. So in this one, I have an x tile and 3 ones tiles. So this is the x plus 3. This side is my x plus 2, because there's 2 ones there. So if I have x times a x, I get this x squared. And then I'm going to do vertically times my 1. So x times a 1 gives me an x. X times a 1 gives me an x. X times a 1 gives me an x. Those are rough rectangles. My apologies. Mateo, did you do algebra tiles at your old school? No? Okay. If you don't love them, totally fine. I'll come chat with you a little bit more later. Then going the other way, I have a 1 times a x, so I still get an x. 1 times a x, I still get an x. This is where it's a little bit trickier here. I have 1s times 1s. So then I'm going to fill these in with little 1 squares. At the end of the day, you want to make sure you fill in the space so it forms the perfect like rectangle or square, depending on the question. In total, I drew an x tile, an x squared tile, my apologies, and 1, 2, 3, 4, 5 x tiles and 6 ones. When you multiply a binomial and a binomial, there's going to be some combining of things, right? Like I had x's in 2 different places, so I can combine them together to make the total of 5 x's. Let's do C, and that'll be my last tiles example. So on C, if they're shaded, they're positive. So I have a positive x on both of these. So I'm going to write a positive x here and a positive x here. On the top, I have 3 negative ones, so it's going to be -3. And then vertically, I have 2 negatives, so then I get -2. These 2 questions are exactly the same, except the first one was positive ones and my second one is negative ones. That's going to change quite a bit in our answer. So I'm going to get x times x, so I still get a positive x squared. I'm still doing x times 1, x times 1 times x times 1. So I'm still going to get 3 x's going this way. Are these going to be positive or negative? Negative. Good, because I have a positive times a negative. If you just want to label them with a plus sign or a minus sign instead of shading, totally fine. Going the other way, I get a negative 1 times a positive x, so I still get a negative x. The big change here is when I look at my ones. I have negatives times negatives. So all of these guys are going to be positive. So in the end, I have a positive x squared. I have 5 negative x's, and then I have 6 positives. Once you've got that, you can turn the page. So, as you know, I find drawing out the tiles really cumbersome. First world problem, I realize that. The next way I'm going to show you how you can multiply a binomial and binomial. It's kind of like a shortcut way. So you can draw it out like the grid, but you're just going to put the symbol or the variable and the numbers in it and then fill it in from there. So let's do the first example here. So if I have 5x minus 6 times 2x plus 1, I'm going to draw out the grid like we do with our algebra tiles. And I'm going to write 5x minus 6 across the top, 2x, and then a plus 1 on the side. I'm going to fill it in just because I think it helps me be a little bit more orderly. But instead of drawing out 5 x's and 6 negatives and drawing out 2 x's and 1 positive, I can just write the numbers. And now I can just do that multiplication. So 5x times 2x gives me what? Go ahead, Charlotte. 10x squared. 2x times negative 6 gives me what? Just showed it out. Negative 12x. 1 times 5x gives me a positive 5x. You do not have to write the plus sign, but if it comforts you, do it. 1 times negative 6 gives us negative 6. So it's a much faster way, but still kind of similar to the tiles, right? We just didn't have to draw a whole bunch of rectangles and squares, which is kind of nice. From here, you have to write your final statement. What is the product here? Well, I have 10x squared still. I have to combine my like terms. If I have 12 negatives and 5 positives, I end up with negative 7x's. And then I still have those negative 6 ones. Don't forget to combine like terms. Khalil, you okay? Yeah. Okay, let's try another one like this. Was that not really pretty? I drew that really well, I feel like. Very clear? No? Teacher thing? Okay. A squared minus 5 is going to go across the top. Notice when I'm writing these, I'm putting it like minus 5 kind of separate. Like it's not subtract 5. I'm trying to make it really clear that it's minus 5. And that's just visually because I think it's helpful. And then I have a squared and minus 8. What is, and let's have answers here, a squared times a squared? Andy? No, we add those exponents. So a to what power? 4, good. 2 plus 2. Then I'm going to have a squared times minus 5, so I get minus 5 a squared. A squared, sorry, negative 8 times a squared gives me negative 8 a squared. What's negative 5 times negative 8? 40. Good, positive 40. Make sure you're watching your integers. So on this one, do I have like terms that I can combine? Yes. So I get a to the power of 4. That's the only guy like that. I can combine my a squares. So I have negative 5 and negative 8 gives me negative 13 a squared. I can combine those guys and then my plus 40. Does that make sense? Is that okay? We're not going to do D. Can you try doing C on your own? C is a little bit tricky, but try it on your own. For my recording, I'm going to pause and I want you to try it. Okay, let's try this one. So remember, the order you write them out doesn't actually matter. Like I flip back and forth, but make sure you keep it together. So like this entire binomial, I wrote on the top. So you need to keep like the order like that correct. That becomes more important when we multiply, say, like a trinomial by a binomial. That becomes more important later on. But just important that you keep it together. So 3p times p gives me 3p squared. 2q times p gives me 2pq. If you wrote it qp, that's fine, but ideally we're putting it alphabetical. 3p times 9q gives us 27pq. Keep them in the same order, be consistent at the very least. 2 times 9 gives me 18. Q times q gives me q squared. So again, I can combine like terms, PQ and PQ, those can go together. So our final answer on this one, did I press record? Okay. I get 3P squared plus 29PQ plus 18Q squared. Raise your hand if you got that one.
I wrote it wrong, but I basically.
Okay, I'll take that, Wyatt. Cool. I like this area model. I find it really helpful. I find it even more helpful when we get into harder questions. It's a way to kind of keep you organized. And it's like you fill in the blanks almost. Like I find a lot of notation in math can be really prompting to tell you what to do next. This example is a really great way. Have you guys seen doing like long multiplication using an area model like this before? So this is where it's kind of coming from. They gave the example, like if I did 32 times 34, right, I would take my 4 times 2 and then 4 times 3, write a 0 and multiply my 3 in. You remember how to do multiplication? If I was to do the area model like this, I would split it into my 10s and my 1s, multiply it, and then you're adding your like terms. You get that same answer, but that's kind of where it's coming from. This is the sort of math that I think a lot of you were probably taught like in, I don't know, when you learn multiplication back in like grade 3, 4, and your parents were like, this is ridiculous and way too difficult. But you did learn it like this at some point in time. If it's stuck, that's one thing. Okay, turn the page. Let's learn method 3. So we're gonna come back to the class example 4 in just a second. There's a trick to remembering how, do you see where I am on the page? Like it's like middle of the page. There's a trick in remembering how to do these types of questions without the area model, without that visual aid. It is using FOIL. So this is something I would highlight, circle, star. This is the big piece to remember. So this like rule or mnemonic is only good when you're multiplying two binomials. So when I have two things written with two terms being multiplied together. The order you can multiply them is we use the acronym FOIL. So first terms, outer terms, inner terms, and last terms. And I'm going to do so many examples doing this method. You ask any grade 11 student, any grade 12 student what FOIL is, they will all rattle this off to you within seconds. This is like your new Pythagorean theorem that you're going to do over and over and over again. It's just going to stick with you from here on out. So let's do an example using this. Let's go back to class example 4. So the first term, I'm going to color code this, so bear with me a little bit. The first term in each set of brackets is x times x. What does that give me? X squared. Our O in FOIL stands for outer. So my outer two terms are an x and a 2. What does x times 2 give us? 2x. I can zoom in there for you. I stands for inner, so I have a 3 and a x, which gives me 3x. And then L stands for last, so 3 times 2 gives us plus 6. So basically, I've just gone through each one of those, made sure everything ended up multiplying together, and now I can combine my like terms and actually get an answer. So x squared has nothing to combine with. 2x and 3x gives me 5x's, and then my plus 6. So all using FOIL is a way to help us stay organized, not mess up when we're making sure we're multiplying everything by everything. We're going to do like 17 more examples of this. So if that didn't stick and didn't feel comfortable, that's okay. We're going to do another one. So let's go to B. I'll try using the highlighter as I go through this. So F, so our first term in each one. So A times 2A, what does that give us? 2A squared. Okay. Now I'm going to do O for outer. So that's our A and 1. What is A times minus 1? Minus 1A. or minus a. Same thing. Totally fine if you don't want to say the 1. So now I'm going to do my inner 2 for I. So negative 7 times 2a, so I get negative 14a. Then we'll do our last. Minus 7 times minus 1 actually gives us a positive 7. 2a squared hangs out by itself. It has no friends. Minus 1 minus 14 gives me negative 15a's plus 7. How was that one? A little bit better. Cool. Okay, let's try. There's a C here, isn't there? Yes. Let's try C. So always, I find FOIL personally the easiest method to use. So our first terms, P times Q gives me PQ. My outer terms, a P and a minus 8, so I get minus 8P. My inner terms, minus 8Q. My last terms are the 8 and the 8. Both are negative, so I get a plus 64. Can I combine anything here? No, every single piece here is unique. So most times you end up being able to combine something, but not always. Okay. Do you guys want to try D on your own? Okay, let's try D on our own and see how you do. Okay, let's try this one together. Or I'll just go over it. I guess you've already done it. X squared, so first, x times x gives us x squared. Outer, O, so that's my x, and 5y, so I get minus 5xy. I stands for inner, so our inner two terms, 4y times x gives me plus 4xy. And then our last terms is our 4y and 5y. I have a positive and a negative, so overall I get negative 20y squared. From here, I can combine like terms. I have xy's and xy's, so those two guys can combine together. Negative 5 plus 4 gives me negative 1 xy. My 20 squared continues to hang out. If you don't want to write that negative 1, totally fine. You can just rewrite it like this. Okay, both of those answers equally, totally correct. Truthfully, we should reorder this so that way the y squared isn't at the very end, right? Because we always want to do degrees from highest to lowest. In a case like this, I just want to see if you can factor, so I don't care. Totally fine to leave it like this. This year, you're not going to do anything with these answers. If you're going to take calculus, so math 31 in grade 12, you would then do something with this answer. And that's when you want to have the order of the degrees from highest to lowest, because then it makes working with it going forward a little bit easier. For grade 10, I want to know that you can multiply binomials. So leave your answer like this. That's totally fine. There's enough things to remember with our math right now. I don't think it's a big deal to make sure we have them ordered correctly. Raise your hand if you got that one right. Rock stars, awesome. Okay, try E on your own. Okay, let's go over this one. So trick here, because we have exponent laws really in this one. So first term, so I get 9a squared times 5a cubed. 9 times 5 gives us 45. A squared times a cubed, I add the 2 and the 3, so I get 45a to the power of 5. How many of you just got that one? Good. Do you see? Like this is grades, like your whole middle school kind of coming together. So that's our first term. O is outer, so I have 9a squared plus 6. 9 times 6 gives us 54a squared. So that was outer. Now I have inner. Minus 1 times 5a cubed, so I get minus 5a cubed. And then my last terms, -1 times 6 gives me minus 6. Can I do anything with this one? No, nothing can combine. I would mark this correct. That's 100% fine. We should really reorder this to make our degrees highest to lowest. So remember, degrees are our exponents. So this exponent's 5, 3, 2. What's the exponent on my 6? Or what's the degree on my 6? 0. When there's not a variable, it has a degree of 0. So we would call our 6 our constant as well. Constants are always last. I didn't show you the distributive property for binomials, like what this is saying above, because it's going to come into play later on, and I think they do a better job of explaining it later on. So just if you're referencing back, our work here doesn't match what they've asked you to do there. Okay, there are 4 more. I'm going to go through these ones a little bit quicker, and then we're going to have some time to practice them on your own. After this, we're half done this unit. Okay, so it is a little bit of a quick unit, but it's also kind of a tricky unit doing this stuff. So use FOIL to determine each product. So this is our first, outer, inner, last. X times X gives us X squared. First. Outer X times 4 gives me plus 4X. Inner X times 6 gives me plus 6X. And then last, 6 times 4 gives us 24. Do you want to go get a drink? Combine like terms. What's 4 plus 6? Oh, come on, guys. 10. You need to talk more. Some of these questions you will start to be able to do in your head. You are going to do so many of these multiplying. If you went straight to this final answer, that's fine. It gets trickier when there's positives and negatives. So in those cases, I strongly suggest writing it out. But if you can do it in your head, go right ahead. On B, y times y gives us y squared. So that was our firsts. And then I have outer y times 2, so that's positive 2y. Inner gives us minus 7y, and then last is minus 14. 2 minus 7 gives us what? -5, right on. Y minus 14. So questions like this, I find it more helpful to write it out. It just prevents you from making a mistake. Easy to forget that it was a -7 versus a +7. Okay, C. First is 3x times x gives us 3x squared. So that was first. Outer, 3x times 5 gives us 15x. That was a minus sign, so it's a minus 15x. Inner, 1 times x gives me a positive x. Last is a minus 5. -15 plus 1 makes us a -14x. This next question is where a lot of mistakes are made. This squared means the entire binomial is written twice, right? If I gave you 7 squared, that means 7 times 7, correct? This question means this is really saying 6a minus 5b times itself. 6a minus 5b. It's the entire thing. It is not. This is the biggest mistake. It's not saying 6a squared minus 5b squared. It is not that. That's the biggest mistake you can make here. The reason for that is if you were to write it out that second way, you're losing the multiplication of our inner and outer terms. And so you're not going to get the same answer. So you cannot just move that to your exponent in. You have to rewrite the whole thing. So when I actually do this one, I get firsts. So I'm going to get 36a squared. First times first. Outer, 6a times minus 5b gives me minus 30 AB. Inner 5b and 6a minus 30 AB. And then my outer, I get positive 25b squared, which gives us 36a squared minus 60ab plus 25b squared. That is your correct answer. If you had done it this other way, which is super wrong, you would have ended up only with 36a squared minus, for how I wrote it, 25b squared. If you wrote it with the minus sign, you could have said plus, just depending how you rewrote it that way. But you see, you don't get that minus 60 doing it that way, and that's why it's wrong. You cannot just move that 2 in. It's the whole thing multiplied by the whole thing. Miss Adam, do you guys know who Miss Adam is? Yeah? In her classroom, she might have taken it down, but she has a poster explaining this for the grade 11s. And she says every time you do this, it's like a meme, you kill a puppy. And she like throws it at kids and writes it all over everything about killing puppies every time. I think it's really funny. Okay, so for the rest of this class, which isn't much time because we only have till about 20 minutes, I want you trying these questions here. Let's not do A on this one. Let's just do C and E on number 1. I'll save one of those tiles for you. 288s.
Are the numbers of the questions on that?
It should be the same ones minus that A. But yeah, they are the same ones. I will have to fix the page number because I copied the page numbers from here. But work on those for the rest of this class. You probably won't finish. You might get close. We'll have some class time tomorrow to work on them as well, though. Okay.